Bright Duty. Every student matters.
Hello dear students, today we will be taking a very important topic, that is the numerical part of light chapter. Before doing the numericals, we must be aware of a few basic terms. Let us see. We have just studied the concave mirrors, the mirrors which were painted from the outer bulging part. This was the pole, this was the focus, and this was the center of curvature, right? Or we have also seen the various images formed when the object was placed in front of a convex mirror, pole, focus, and center of curvature. Now, in concave or convex, either of the mirrors, we have seen that we have placed the object either between P and F or at F or anywhere in front of the mirror. Now, the distance at which this particular object AB was placed, that is known as the object distance. I repeat, what is object distance? It is the distance at which an object is placed from the pole of a mirror, and this distance is denoted as small u. In this particular figure, what is the object distance? This is the object AB. We will see this B, how much far it is from the pole. So, this is PB. PB will be our object distance. Fine. Then we have seen that if we have placed this object over here, then we got an image, either it was behind or it was in front. Taking both the possibilities, this was our image A dash B dash. Now, the distance at which the image is formed from the pole is known as image distance. I repeat, the distance at which the image of an object is formed is known as image distance, and it is expressed as small alphabet V. And over here in this figure we can see that from P till P dash, this PB dash is our image distance. If the image was formed out here, then P to B dash is our image distance. Now students, in 9th class we have studied small u and small v were used for initial velocity and final velocity, but over here in optics we use small u and small v for object distance and image distance respectively. And all the distances are always measured on the principal axis from the left or the right from the pole. Fine. Another term that we should be aware of is focal length. Now, what is focal length? It is the distance of the focus from the mirror. This was the focus of a concave mirror. Now, the distance at which this focus is formed, this will be the focal length, which is expressed as small f, and in this figure we see that P and F, this distance PF is the focal length. In the case of a convex mirror, if we have taken an object AB, similarly P to B, this will be our object distance. The image was formed here somewhere. This was our image A dash B dash. P to B dash was our image distance, and the focus was formed here on the right hand side behind the mirror. From the P point to F point, this will be our focal length. Right. So, we should be aware of these terms: object distance, image distance, and focal length. Right. These are the three distances that we have talked about: object distance, image distance, and focus distance. Right. Another point we need to know is height or size. We will be talking about either the height or size of object and the height or size of the image formed. Looking at the figures, we can say that the size of the object is AB in either of the mirrors. A to B, this is the length of this object above the principal axis, this is, and A dash to B dash, this is the length of the image. This will say that this is the height or the size of the image formed. Fine. we can express the height of the object to be h1 and height of image to be h2. Some students prefer it this way: height of object is expressed as HO and height of image is expressed as HI. Either of the two you can take, both are fine. Alright, so this is the height or size of object and height or size of image. Now we need to know two formula. First of all, we will be studying about mirror formula. What exactly mirror formula states is 1 by f is always equal to 1 by v plus 1 by u, where f is our focal length as studied earlier, v is our image distance, and u is the object distance. So this is mirror formula, and this mirror formula 1 by f is equal to 1 by v plus 1 by u is applicable on all type of mirrors, whether it is a plane mirror or a concave mirror or a convex mirror. Fine, right? Next we will be studying about is magnification. First of all, we need to understand what magnification is. Magnification, by magnification I mean to say that how much magnified the image is as compared to the object. For example, I have represented the height of object to be h1, let it be 2 centimeters. Now, if the image which is represented by h2, this is formed 2 centimeters in height, we will say that the image formed is same as that of the object. This is the same size image, right? But if the image formed is 4 centimeter, now it is doubled. So I will say that this particular image is magnified, and how many times? 2 times, right? Similarly, if the image formed is 1 centimeter, I will say that the image is diminished, or it is half times magnified. Why? How have I calculate this particular magnification? There is a formula for it. Magnification is represented by small m, and it is given by the formula h2 by h1, where h2 was the height or size of the image and h1 is the height or size of the object. Fine. Taking all the 3 cases, for example, first case was the height of the object was 2 centimeters. Fine. The image formed is of 2 centimeters. Then I see that the value of magnification was coming out to be 1. I have cancelled 2 and 2, and along with that I have cancelled the units also. So magnification has no units of its own. You have to remember that magnification is always expressed in number of times. How many times magnified image we are having. Taking next case, I have represented magnification with the formula h2 by h1. Now, if the size of the or height of the object was 2 centimeter and the image formed was of 4 centimeters, then using this formula I say that the magnification is 2 times. Clear? Third option, magnification represented by same h2 by h1. The size of the object was 2 centimeters, and if the size or height of the image is 1 centimeter, then I will say that the image is 0.5 times magnified. Fine. So this is how we represent magnification, number 1. Number 2, magnification has no units of its own. This magnification is expressed in number of times. Now, the magnification can also be expressed by a different formula, which is magnification is equal to minus v upon u, where u is the object distance, v is the image distance. Right. So, I have got 2 formula for magnification. One was magnification was given by h2 by h1, and another is magnification is given by the formula minus v upon u. So, I can write it this way also: magnification is equal to h2 by h1 is equal to minus v upon u, right, where I should know the meaning of all the symbols over here. M is magnification, h1 is the height of the object, h2 is the height of the image, u is the object distance, and v is the image distance. These two formula, one is of magnification and another is the mirror formula. These two formula we will be using for doing all the numericals in this particular topic. Fine.